Okay, let's start. Welcome everybody, both in person in the auditorium and on Zoom and on YouTube live, to the 7th in the IIA SCOPE Seminar Series, which features talks both on outreach and education as well as the practice of outreach and the history of astronomy. The last couple of talks we've organized have started off saying which century the work is from, and there is no exception. Today we're going to have a talk on a 17th century manuscript by Dr. B.S. Shubha here. She completed her MSc in mathematics from the Bangalore University with fluid dynamics as specialization, and then she changed fields, went to MES College in Bangalore, where she continued a study on ancient manuscript called Mahadevi Deepika, and for which she was awarded the MPhil. And then she switched gears and did her PhD, which was on Brahmatulya-Udāharaṇam, on which today's talk is going to be, of Viśvanātha, which is from 16th or 17th century, which she did from the Sassoon College, Bangalore, along with Dr. Vinay and Dr. Shailaja, who all of you know. She then extended her studies on medieval period manuscripts in Sanskrit by Ekanath, Padmanabha and Sodala, who were Sanskrit-based astronomers from that era. She also worked as a lecturer and research associate for more than 3 years at Pune Pramati, and her priority is ancient Indian mathematics and medieval era Indian astronomy. She's currently working on a new manuscript called Mahadevi Sarani from the 13th century. So we'll have to talk about that later. Written by Mahadeva, which has true longitudes of locations in India rather than reference to Ujjain or something like that. Right? She's also working on other manuscripts on maths and astronomy, sourced from the Bhandarkar Institute in Pune as well as from Jodhpur, along with Dr. Shailaja. So now I invite Shubha to please come and tell us about this 17th century manuscript. This is, I think, a relatively new manuscript for us, given all the other centuries we've been working on. So please.
Good evening, everybody. I'm really honored to see so many people here. Generally, the number of people who attend the history part is very less, but still, many new faces. I'm excited and really happy to see many of you. Thank you for spending few minutes with me. Definitely, I won't take much time. Okay, so to start with, Brahmatulya-Udāharaṇam by Viśvanātha. So, this is the front page of the manuscript. Initially, when I started, when I had the manuscript in my hands, it was Greek and Latin for me, and I was thinking what I'm going to do with all these things. Editing was really a challenge for this. So, this particular manuscript, it had been procured from Pune and Jodhpur, from all these places. I had to travel all over those places. And of course, there were almost 230 folios, a small manuscript to look like, which was edited for this Brahmatulya-Udāharaṇam, and for this entire work actually I had selected 530 folios manuscripts. This is too lengthy and it exceeds the time, so I have cut limited to only just Brahmatulya-Udāharaṇam. So the interesting thing about these manuscripts are you have verses which depict the numbers in the Bhuta Sankhya system. Like instead of saying that number as 2, they say as Nayanar eyes. Instead of saying as number 10, they say it as Dik, direction. So like this, editing was again a challenge because some of the letters were not, can you hear me? Because it was not clearly visible. Sometimes they write in the margin, you have to understand where this line follows, where it has to be which after this line, which line has to be followed, like all those things. And the present day, what manuscript, Sanskrit, what you study, it's not in the same way what you find in the 12th century or 13th century, because they just write individual words. They don't write letters instead. They won't write it as words. What you study in Hindi or Sanskrit, like that, you don't find them in the form of words. We find each one of them in the form of small letters. So you have to understand which is that particular word. So this work itself, takes too much of time. Moving on, Brahmatulya-Udāharaṇam is based on Karaṇakutūhala of Bhāskarāchārya II. This is the first work written by Bhāskarāchārya in the 12th century. And of course, this particular text, Brahmatulya-Udāharaṇam, it contains examples of 17th century. It has examples of all the celestial events that he has observed. Observation part is what is important for us from that particular century. Almost all texts of the medieval period are based on the work of Bhāskarāchārya. We can identify a systematic evolution in astronomical calculations. Then the popularity of different texts can be established from the improved illustrations and commentaries written on them. Just this Karaṇakutūhala has more than 16 different commentaries from different centuries. And specifically, the commentaries improve the parameters and computational proficiency of the original text, and of course, they yield better results for the position of the planets. And the precision corrections have been developed over the years. It's not just what Bhaskarāchārya told in the 12th century, same thing has been adopted. Over every century, they have improved all these corrections, precision corrections especially. So coming back to this author, Viśvanātha, I have become a fan of this particular author. He has written so many commentaries from the 17th century. He was the son of Divakara of Golagrama, and because he has written in the colophons itself. And all the calculations, whatever he has done it for Varanasi. He was well versed with other texts prior to him, as evidenced by the citation of the 12th century text Mahadeva Sarini. That's what I'm working on, the next one, which was being used to find the true positions of the planet. During that time, finding the true positions of the planet was really a very good task actually for the astronomers especially. And in the present text, he refers Mahadeva with great respect. Fortunately, the text what I was doing, in the front page itself we had all these references that led to me to the study of this Mahadeva Sarini. And some of these works are Gahanartha Prakashika, commentaries on Makaranda Sarini, Grahalagava Tika, Patha Sarini, Siddhāntic, and many more. Here I'll be speaking only about some of the events: eclipses, retrograde-motion, Shringovnati, and conjunction of planets. Before understanding all these celestial events, how they started about is what is important for us. In any text for that particular matter, we have a chapter called as Madhyamadhikara, or finding the mean position of the planets. That's what they do. How they start about? The procedures for calculation of the positions of planets in Indian astronomical texts, they require a basic parameter called known as Ahargana, which represents the number of civil days elapsed from a standard epoch to the current date of the text. So how they do? It is just one verse. To memorize, it's very easy. Shakaha Panchadik Chandrahino Arkonigno Madhuho Vyatihi. They never used to call it as Chaitra, Vaishaka and other things. They used to call it by the name Madhu, Madhava and so on. And during those times, that was the names were used for the lunar months. Then, how do they do? For Bhaskarāchārya, the epoch what was adopted was 1105, that 12th century. That is the epoch he is starting. That is the beginning point, whatever he takes. Then, when he says Shakaha, that is the epoch what he adopts. Panchadik Chandrahino, has to be reversed. Pancha is 5, Dik is 10, Chandra is 1. So the epoch becomes 1105. They write it in the reverse order. That's how they follow in all the text, whatever they write. Then Chandrahino Arkaha. So suppose you are taking 2024. So from 2024, you are going to subtract 1105 first and then get that particular number. Then after finding that number, then you have to multiply it by 12. Arkodiknaha. You are multiplying it by 12. Dvinignat, sorry, it's not 12, it's Dvinignat. So you are multiplying it by 2 to get the tithis. Like this, we proceed. In 2 verses, there are 15 different steps which you have to understand to find out what is the first one, that is Ahargana. And in this, they adopt a method called as Vara Samyata. Means whatever they have done, whether it is correct or not, to find out, after getting that number, they divide it by 7 and find out whether today it is Tuesday, Wednesday, whatever day it is perfect or not. So like this, they start about. So this is the first step in all the text.
Sorry to interrupt, there's some audio issues. Could you put the mic a bit? People online are having some issues.
You have to stand in front of the mic itself.
No, actually this is not picking up.
This has to be higher.
Now I think it's clear.
Should be.
So like this, they have 15 different steps from the first verse itself. It's not just first chapter, from the first verse. So after finding this number, then they find out the mean position of the sun. For that, in order to, whatever verse they have given, I have shown it in the form of an equation, where A is nothing but the number. Suppose if you take for this century, 2024, then whatever number you have found out, for that number, A plus 13 times A divided by 903, it's like that you can make an equation. Then you find out that number. For that, you have to add a quantity called the Kshepaka. These are the constants what has been found out by Bhāskarāchārya in the Karaṇakutūhala text for that epoch. That is for 11th century when he has done, that is the position of the planet what he has found out. For that, we have to add this number. Then we generally read it as Rashi, Amsha, Kala, Vikala. That is 10 is 10 into 3, 300 degrees plus 29. 300 plus 29, 329 degrees, 13 arc seconds plus 13 minutes and 0 arc seconds. Like this, we find out first the mean position of the sun. Then, with this, it does not end. After this, we have something called as corrections which has been developed over the years. Like when Bhāskarāchārya has done this, the correction what he has applied is very little. Whereas, over the years, by the time Viśvanātha has improved this, he has applied some other extra corrections. As I move on, I'll tell about those things. Deshantara correction, that is longitudinal corrections, all those things they keep to apply. After this, a correction for elapsed number of years, what we call it as annual corrections or Abda-bija corrections. For this epoch, how much such corrections has to be applied. So that is the amount of care they used to take to find the positions of the planets. Then, during the 7th century, there was an astronomer called as Ramachandra-Acharya. He has specifically given some more extra other corrections called as Rama-bija corrections. Again, those corrections are also applied before finding the true positions of the planets. So this is the equations what we obtained. There are about 22 verses in this first chapter. From this we find out first the mean positions of the planet, mean longitude of all the planets. Then that was done. You can make out it is 1534. It corresponds to 1612 CE. Please make note of this, because as we proceed, we can clearly make out that Viśvanātha has done astronomical observations, because the eclipse is what he refers, it will be from 1610, not from 1612. So that was a proof that astronomical observations has been done by this astronomer. So you can make out this is the manuscript photo in between what I have. In the margins he has marked especially those corrections there on that side. Rama-bija corrections, Deshantara corrections, Abda-bija corrections, like this. These are all written in the last and they tell that in detail to adopt all these corrections when you are doing the calculations. So this is about the, after finding for 1612, that was the mean longitude. Then for the longitudinal correction, Deshantara corrections, then Abda-bija, that is for that particular epoch. Then we have Rama-bija corrections, that is the corrections what has been given by Ramachandra-Acharya. All those things has been adopted and given you only the final values there, that's all, nothing else. Then the next chapter, that is only to find out the mean positions of the planet. Next is they move on to the true positions, as the name says, Spashtadhikara or Sputadhikara also, some of them they say these names. So the method of computing the true positions of the planets from their mean positions is done by Viśvanātha in the chapter titled Spashtadhikara, and of course there are about 22 verses through which we obtain the true positions of the planets. Here we have, there is something called as Manda and Shigra corrections. You can make out from the picture clearly there. Initially when they apply the mean positions of the planets, it was that once they apply these corrections, you are getting that elliptic order. Correct? Automatically it's corrected. Nowhere they mention the name of elliptic order or anything else. But they automatically do this, apply these corrections and apply the true positions of the planets. That's what is done in this particular chapter. It's not just that, they also find out what is the Tithi, what is the Karana, Yoga, all those things as a part of the exercise as in those manuscripts what they do. You can make out clearly, I've given you the values for Mars, the iteration part. Instead of using the word iteration, they are used called as Pratama Parivarta, Dvitiya Parivarta, Tritiya Parivarta, Chaturtha Parivarta, Panchama Parivarta, and so on. You can make out the values keeps on changing, and they repeat this procedure until they get the convergence up to arc seconds. From third to fifth, you can make out, they have done it 3 times. They are making sure that no more the value changes. So the convergence of up to arc seconds. This has been done in the 16th century. You know that Newton-Raphson method, what you have studied in college days, it was developed in 1672. But this has been done prior to that, 1612 itself, it has been adopted. That's a speciality of the astronomers. Nowhere they give us the meaning of convergence or anything else, but automatically they have used it. Then, in the next chapter, Triprashnadhikara, the 3 problems have to be solved first. Direction, observers' positions on Earth, time for fixing the position of any celestial body, all those things has to be done. There are about 16 verses through which we attain this particular procedure. The first exercise is to fix the location of the observer and then do the necessary, derive the necessary constants required for the astronomical observations. And these constitutes the contents of the chapter Triprashnadhikara. I am not going detail into this because you have seen in the first sloka, it's the first verse itself, it has 15 different steps. So to explain each verse and to explain each and everything, it takes too much of time. So I am just moving on with the celestial events. So how they did about all these things. First is about the lunar eclipse. In this chapter on Chandragrahana, we have an example of a total lunar eclipse that had taken place in the year on December 9, 1620, that is according to CE modern. Then the precise longitudes, the instant of eclipse and the duration of eclipse, all these things has been calculated by the method of iteration. The same thing, they use a word also called as asakrit, pratama parivarta. Applying all these things, they find out all these things. They do these steps up to 7 steps. Then after applying all these corrections, we find the position of the sun, moon, and the timings of the eclipse, everything. This is what the table I have given you. So for about 1542, you can make out here it is 9th December 1620. Example what I have given you. The Ahargana, the first thing what I told you when I started, the first verse, how they found out the Ahargana value, then using that, how they find out mean positions, then how they apply the Deshantara, Udayantara, Manda corrections, Chara corrections, all those things. Then they find out what is the duration of the day which is left over, what is the duration of half night, then the Nata correction, it's a small corrections what we have, it's our angle what you have find out. They use the different terminologies altogether. Then we have Hara values, Nata corrected values after finding all those things, how they correct it for the true positions of the sun and moon, and how they find out the instant of conjunction. They call it as Parva. So all those things have been worked out and it has been tabulated here. Similarly, they find out Bimba, Bhuba, Sthiti, all those things. They find out the eclipse. There are procedures. They describe in one verse. We have to understand that particular verse and then use that method and apply all these things in order to find these values. The interesting part is Parilekana. It's a geometrical procedure to find out how the eclipse looks like. The entire thing is only the steps. I'll give you just the procedure. The right hand side what you are seeing is the picture of the eclipse for a different eclipse. It has been marked by Viśvanātha in Siddhāntic-Udāharaṇam. It's not from Brahmatulya-Udāharaṇam. And this is what the picture what we get as following those steps given in Parilekana. That is the steps he says. They mention somewhere in between as Madhyam Upavidya. You should understand it's a fish-like drawing. What does it mean? We never understand because we are not used to such type of diagrams. Those diagrams were used in India before especially when they did the eclipse diagrams and other things. Especially in Sulabha Sutras, they used to do all these things to find out the position of the line. When you want to divide a line, all those things, those procedures they were adopted in those texts. They use the same sentences there, assuming that we know all those things. So it took lots of time to understand these things also. This is what the comparison we got from NASA picture and what we have done. Please see only the umbral part, so how it matches exactly from those things. Then similar to it, we have for Surya Grahana also. Here the main difference is the procedure in applying the parallax correction for the location of the observer. That's what is important in this. Again, same procedure it follows, but here the number of iterations and the number of steps exceeds still more just to find out the timings of the eclipse.
Then, moving on to retrograde motion of planets. In the chapter called as Udayastha-adhikara, they give about all these details. The formulas for this, as devised by Bhāskarāchārya, are provided based on the earlier works itself. The examples we compared with the calculations from Stellarium using that. Then the values for Mars and Jupiter, they agree approximately, while for Mercury, it is not in a very good agreement. We have also used some Sarini tables for these things, which I am working on. The error in Mercury might be because of fixing the initial positions of the planet. Instead of telling about those things, suppose I've given you one example of Mars, how they do. For the day of the calculation of we find the Shigra Kendra of Mars as 322. It's 3 rashis. 3 rashis means 3 into 30. 90 degrees plus 22. You add up all these things, that's how you find the position of the planets. And in order that the required value, you can make out that which is 102 degrees, 29 minutes, 34 arc seconds. So in order to in the table they have mentioned that for 163 degrees, the retrograde motion is going to happen. So in order to achieve that 163 difference between is nothing but 50 degrees. In order to achieve that, you require about 11 days and 41 gatis and 16 vigatis. That is a time unit what they used to use. And adding to this 111 days, we'll get it as it's the Shravana Masa. That's October. When you start calculating from that particular day to this day, how many days has been elapsed, and how many more days you require. You have to find out when the retrograde motion has to take place. So like this, when they do the calculation, they find out that for the Margashira Shukla one, this particular event is going to take place. It is a retrograde motion. It will start going to move forward in forward direction. So this is what the table, after doing all those calculations, what we have achieved and what we have calculated. Then the next is nothing but the conjunction of planets. It provides one more example of Venus and Saturn, which we were actually able to calculate by actual calculations also. And the difference what we found is 12 angulas. It's very difficult to identify such a small thing through naked eyes. Might be during those days the sky was more clear, or you used to stand in some different places. So see, you can make out it is 1610, the conjunction what he has made. So he has recorded all these things. Astronomical observations he has done for a period of almost 20 years. Then he has continued with all these things. And our enthusiasm did not stop here. How it is going to apply even for today? That made us something more, work still more. So I think everybody knew that the Venus and Jupiter conjunction last year, what we could see through naked eyes, you must have recorded through telescope also at IIA. So Venus and Jupiter provided an opportunity for us to do all these calculations. So we obtained the longitudes for the whole year at intervals of 14 days. We calculated for the entire year, but we were smart here. We used the Mahadeva Sarini, which I am working on, that particular text also. Then a graph was plotted. Then we found out what is going to happen. The conjunctions was read out as 357 and 345 degrees. Can you make out? There were two conjunctions that was seen last year. That is between 2022 March to 2023 March. During that time, that is the year what they calculate. So we could see two. That was the date which took place on 30th April. On 1st March it was this. This was the calculations done by us on what is the 17 angulas. That was the difference what we could find out. And this was the picture taken at IIA itself by Geeta, one of my friends. So conjunctions, whatever they applied during those times. So even to this day, it is still valid and we are able to verify it also. Then the interesting part is, they had given us a special name called as 27 stars and the method of using them for how do you find out it is called the ascensional difference in terminology is what you use. They give 27 star names. I will show you with this. This is what the verses were. So by just seeing the verse, you don't understand everything. It was written in the separate sheet, all these things. So what is interesting, I was verifying. So they had also marked a small numbers there. What is it? That was also a challenge for us. So when we move on, I'll just refer to just first verse. It says, Dasram kamadhye pravilokayat yah karoti shakramsha abhiyoti. So Dasram means they are referring to star Ashwini. Kamadhye is you are seeing on the meridian. When you see Ashwini on the meridian, and similarly Samyugyati Yamyam means Bharani. Similarly Siddhāntic is the number 24, Shakramsa is the number 14. Like this we have to identify what they say in just one verse. So actually the total meaning is when one says Ashwini in the middle, that is on the meridian, the degree value is Amsha is 14 degrees. Similarly, when we use Bharani, it is 24 degrees. Then for Kritika, it is 9 degrees. Then the Lagna ascendant is Leo, he says. So we didn't understand how it is possible to have an Ashwini is on the meridian. This is the math. So we went on analyzing all these things. This is what we could arrive. So longitude of the point B, that is on the star, when you see on the meridian. So Ashwini is, because he is saying on the meridian, we went on adding 90 degrees to it. So once we added 90 degrees, it turned out to be 104 degrees, 114 degrees, 129 degrees, and so on. So for all the 27 stars, we could get like this. Then, what he is saying, we tried to analyze. The paper is going to come out with all these details. Suppose you have a point P, a star, then the angle, I'm not going to detail of all these things because all of you are astronomers, you know better than me about the stars. Angle SPS dash is nothing but gamma PS minus gamma PS. It's nothing but arcane. That is the amount of distance that the star has to travel about. That gamma is nothing but your first point of Aries. So we tried plotting different things taking into consideration. One thing what I am showing is the declination of the star versus the declination of the ascendant. So this is what the graph, what could we get? Why is this deviations? Only certain deductions what I have concluded. The deviations from the ecliptic is easily noticeable. It is clear that the correction corresponding to the latitude what they have applied. Because he clearly says in that particular chapter that this is only for Varanasi what I am doing. And later we found out that in all the places they have like these tables and they have their own method of identifying the Lagna. Recently we came across a book by K. Krishnamurthy where he refers about all these Lagnas and stars and everything. It is published also. In this method of observing the star to pick the ascendant, observational details or practical details, they are not explicitly mentioned. They just give us those verses and leave out, that's all. They assume that we know all these things. So we draw the attention to the points in the graph corresponding to star Mrigashira, Purva Bhadra and Revati. Of course, you can make out clearly. Mrigashira might be they have identified star as Lambda Oriae, which is very fine. Because of this discrepancies, this might have happened. Similarly, instead of observing Beta Ligis, there's Zeta PCS, a very faint star might have been observed. And again, the same case, even in the case of Purva Bhadra also. We have taken many other concepts into consideration in the paper, which is going to be finalized. Sure. Shrungonati, the next thing. How the crescent moon, observation of the crescent moon was most interesting for all the astronomers during those times. The procedure is to calculate the orientation of the horns of the crescent moon. The visibility of thin crescent generated lots of discussions among astronomers long back also. And this is essential to calculate the orientation shape, which amounts to the determination of the phase of the moon, how it is going to look. And the procedure verifies only for the crescent moon, not for other things. These are the details what we have gone through all these aspects. This is what here also they give it's called as Parilekha for this also, how to obtain the diagram for all these things. This we have done for different values also. The orientation, it is decided by the declination of the moon and the latitude, and the calculations gives us all these details. Coming back to the all these examples, they are reflecting only what? The efforts to improve the accuracy in computation of the precise positions up to arc seconds and timings for all the celestial events like eclipses, conjunctions and retrograde motions. And you can see that in the entire text, almost all the events have been covered, exhaustive coverage of all types of celestial events. Observational evidences can be traced especially in the calculation of Lagna, which is done during the night as well as in the planetary conjunctions also. Iterations methods could be demonstrated for the first time. This is the only test which we could see from all over the text what we have gone through, where they mention about the iteration process, how they have used it. And we have discovered many forgotten astronomers like Ramachandra-Acharya. They also measure about Bhojaraja. And during those times, there was one more commentary by Ekanath. He mentions more than about 25 different astronomers and 25 different texts. We are not at all aware of all those things. That work is going on. So the examples have been described in great detail, giving the scope for verification also. And Brahmatulya-Udāharaṇam of one of the Viśvanātha is best because we can understand the Siddhāntic procedures with practical examples of all the celestial events which has occurred over the years. And of course, the observation part he has done and then recorded all these things. Because of this, we can clearly make out that he has observed all these things. Because one example, if he gives for 1610, then he gives for 1620. In between, only the eclipses, what he has observed, he has recorded. Because we had proof from NASA. When we compared it from the NASA, we found that there were many eclipses, only the eclipse which was visible in India, that has been recorded by him. So that was again one more proof for observational astronomy was there during those times also. Then of course the future studies in upcoming years will bring in many light to many such more manuscripts. I'm working on 3 more manuscripts simultaneously. So any questions? And these are all the astronomical events what we found out in the entire text. The Jupiter conjunction, Venus conjunction, declination, all those things. You can find out the dates from 1610 when we started to 1630. Almost 20 years he has taken for the entire astronomical observations to give us all these details in this entire manuscript. Viśvanātha has written more than 3 different manuscripts with the same example of eclipses, but he refers to different astronomers and different methods of calculating all these things. And this was just one portion of my thesis work. I thank Dr. B.S. Shailaja Madam and Dr. Vinay P. Who are the guides for during my thesis work. I also thank IIA for giving me an opportunity to present my work. Thank you all.
Thank you, Dr. Shubha. I think that was a tour de force covering, starting from linguistics and ending up in astronomy and passing by algorithms and a lot of our high school maths, which we probably have forgotten by now. I think this is the great example of how not only there's a lot of work being done already, but a lot of work needs to be done in identifying manuscripts, unearthing them, interpreting them, redoing the algorithm, verification, and try and figure out how there were corrections and observations happening throughout the centuries in various parts of India. So people on Zoom and YouTube, I'll request you to type in your questions and we'll take them. In the meantime, we'll take questions from the auditorium here. Yes, the mic will come to you because people online need to hear your questions.
Hello. A very nice talk. So what you presented was from the perspective of astronomy. I wanted to know that were there any astrophysicists at that time who used to interpret these observations, trying to interpret the geometry of eclipses and motion of planets, just like Kepler used to do for Tycho Brahe.
Yeah, I understood. It's the same question what you had for Laghumanasa also. There is no model concept part. Here what happens is they measure the angle. So whether who is at the center, who is at the back, but nobody is bothered. We are only measuring the angle. Because of this, we don't have any specific models in this particular text, whatever I have gone through and so far. And I think telescope is something which is new here in this particular era, where you can have more number of observations and other things. The only observation what we came through was Nalika Yantra. It's just a citation tube. With that itself, they have done so much of work. Then probably, if we had given them telescope, they would have done much more better work than us.
Are you thinking for the cause than
Yeah.
observation?
Yeah.
even come across any text like that.
Yeah.
Like, why do planets move this way
Yeah.
at all?
Yeah.
Why do you have to apply these corrections?
Yeah, and
These
all those
questions?
values, especially when retrograde motion was taking place, who told them that at exactly at 168 degrees it is going to retrograde? Today you are observing through telescopes, you have proof, everything. But during that 12th century, it's not even 16 or 17, because Viśvanātha at least he gives examples from 17th century, I can say. But for Bhāskarāchārya, who gave them all those things, ideas? And of course, it's their innovative ideas and thinking capacity. And still interesting concept is from Bhaskara Aryabhata. When ma'am was telling about Labhumanasa and the works prior to it. After that, in each of these astronomical works, we see the gradual improvement in the precise applying the corrections or improving their own methods. Then, especially in Eknath's work, we were seeing that he has condemned clearly Lalacharya, saying that what Utkramadhya, you are using R sign inverse, that is completely wrong. You are not supposed to use at this particular point, especially while calculating Valana. So when they are referring to eclipses and other concepts, they go back to their previous astronomers, they have studied what they have told and they have criticized why I am doing this, why it should not be done. All those things has been done in these manuscripts. The only thing is, we have lost all these things. Over a period of 100 years, hardly we can't understand either those letters itself. So, still we are able to find out at least one or two. That's, I think we are lucky enough to have such big astronomers in our
Okay, so my question is, many of these predictions, do they require that Earth is at the center or Sun is at the center, right?
No.
I mean, some of these, like modern predictions would definitely have those assumptions built in those models, but earlier, before the 16th or 15th century or even before, did they make any of those assumptions or it's not needed at all?
At least as far as in the text what I have gone through as per till now, I have not seen any such references where they make this as center or something as center. I think ma'am knows better than me. She has 40 years of experience in this particular field. From till now, whatever text I have gone through in that, I have not seen any of these things.
Yeah,
Yeah,
can you
please.
get the mic?
The basic point was to explain what you observe in the sky. So obviously it is Earth-centered. As you see in the sky, you are the center of the universe. So everything is explained with respect to that. And the associated part, namely whether you keep it the sun at the center or something, was indirectly known because in one of the things, especially in retrograde motion, they say that the position of the sun relative to the earth and the planet is important there. So how do you fix that 163 degrees or whatever? It's decided by that, and in that context, they knew that Venus and Mercury were always going round the sun. They would be on either side of the sun. So if you want to calculate the main position of the planets Mercury and Venus, you take the sun itself as the center and apply the necessary correction, how far away they are from their respective apogees, aphelion points. So this was known, but then they didn't make a model as such. So by 14th century, when Nilakanta Somayaji made the model, we get an idea that it has the earth at the center, the moon going round it, the sun going round it, Venus and Mercury will be going round the sun, which is something similar to what you see in Tycho's model. The same kind of analogy comes here also, but they did not declare that this is a model or anything. Those words you don't find that in any of these.
You know, Nilakanta's work, he says so explicitly, right? All the planets go around the sun, sun goes around the earth.
No, that is not directly mentioned.
Not right.
The model, if you
Says that.
transfer them into a drawing, it amounts to that. He did not say that.
So while we take more questions, people on Zoom and YouTube, I request you to type in questions. Yeah, please.
So like my question is more towards the history side. So what was the oldest document regarding Indian astronomy that you've found so far?
Syllabus sutras. The geometry, construction part is what we have found, and they've been using it also.
Some 700 beats.
7. And the construction part, what is described, it is still more interesting, and I think Professor C.K. Raju is attempting to bring out a version of these things so that instead of teaching the Euclidean geometry in India, why don't we teach the Syllabus Sutra geometry? He is bringing out certain concepts in this also.
There's one question, YouTube, asking you to explain a bit about what you mean by conjunction.
Conjunction is
No, in the mic.
I think you can give it to Mom, she will tell. No, you can give us better example.
Conjunction is just the planets coming to. We saw it.
Okay,
We all of us
yeah,
saw it.
I showed you in the picture also.
So when the two bodies in the sky come together, that's called the conjunction. It could be two planets. It could be sun and the moon. It could be moon and a planet, anything. So that is called as conjunction. So the mathematically you can put that the longitudes of the two should be equal.
The other questions.
Two planets coming together, and I think recently also we had
That photograph.
two planets. Here I have taken Jupiter and Venus and Saturn. The next picture, previous one. I told also it's the conjunction of Venus and Jupiter. Any more questions?
Yeah, so I have another question. Many of these manuscripts that are available now, they are written in old Sanskrit,
Devanagari,
right?
yeah.
And most of it may not be in practice today. Or is it like the language has evolved, right?
Language has evolved, no doubt.
So I mean, to interpret your finding and results, you have to depend on someone else who are expert in those languages, or how do you go about this? Seems like a very complex thing.
Yeah, I agree.
Right.
Basic knowledge of Sanskrit is definitely required. Without that, you can't proceed with any of these things. And it is not just in Sanskrit, we have regional language text also, manuscripts also available. From ORI itself, we had Kannada manuscripts. So some of these Sanskrit manuscripts have been rewritten in Kannada, so that you can follow it easily. And from Jodhpur and Rajasthan, other places, you find manuscripts in those regional languages itself. Whatever the same text has been rewritten in that particular language, where you can go through those things also. And of course, something have changed, but as you get used to it, I told you 530 folios. By the time I finished, now I can read any manuscript for that matter. If you give immediately, I can study. So automatically you get used to it. Initially, it becomes one or two places instead of reading sha. Even I had made certain mistakes like stapita. I had read everything as chapita. That particular regional influence of language was also there, especially in certain texts. So all those things you have to get used to it when you are doing.
That makes you not only expert in ancient astronomy, but also a scholar of languages, right? This is a great feat in itself. Yeah, thank you.
When I started in 2013 these things, so whatever language I knew, I thought, okay, it's not sufficient. Then I started attending all the Sanskrit classes also, especially the grammatical classes and other things. By the time I realized that to master in any one subject, you require a lifetime. It's not so easy. And especially when you are a child, if those things are imposed, it comes out easily. After certain age, it's very difficult to memorize certain things. But as you keep hearing those things, automatically you get used to it. Now my hobby has become, I read only Sanskrit journals and instead of these English.
The work done by Shailaja and Puneet in Mysore, for example,
Yeah,
they first have to read the old Kannada script, then understand the old Kannada language, then they translate to modern Kannada, then they do English, and then they do the maths after that. So it's a multidisciplinary project.
That's why Sanskrit University gives interdisciplinary topics prominently important. When I said that I'll just transliterate and give it back, so then said, who is going to study this? So then they forced me. Okay, I agreed. Okay, I'll do it. And then I took it as a challenge. And because, of course, I was from mathematics background, so I had to attend both astronomical classes at REEP, then at Jain University, and all these places to understand these astronomical concepts also.
Other questions? Yeah.
Yes.
Mike.
So any of these documents mention anything about any schools of astronomers or where any places where these astronomers are doing work or anything like that? Information is given anywhere?
We didn't find any place or anything else, but the number of astronomers and the number of astronomical texts were numerous. I especially work the next, what I'm having is Ekanath's work. In that we have almost 25 different astronomical texts. We are not aware of it also. And there is no schools as such. No schools.
Except for the Kerala school.
But I'm talking about a center where, I think they won't be random. I mean the school in the sense of center where people are gathered together for discussions or some observations, or because we don't come across any calculations done, detailed calculations done, or observation log. I mean, somewhere they have noted down things. Some place they would have stored somewhere, right?
One more interesting thing is they have a ready reckoner for all these things. When you say Karaṇakutūhala, they have a Karaṇakutūhala Sarini. When I say Brahmatulya-Udāharaṇam, along with this we have a Brahmatulya Sarini. I had edited that also, I didn't bring out here. It's almost 230 to 33 folios. When you say Vanda Kendra is this much degree, sign this day, just go to the table and find out that and just put it like that. Ready reckoner part they had long back.
That's an interesting question from YouTube, from Shashwat. Do you have any comments on the exchange of ancient mathematical knowledge between India and other cultures a few hundred years ago?
Not from this text.
No, it's a general question.
General.
Varanasi had many scholars who were trained in Islamic astronomy also. So there are books with title like Tajiki. Tajiki means
Tajaki, Yantra, Tajaki.
So there is a Tajiki Nilakanta.
The other question from YouTube, is there any textual description of how Bhāskarāchārya II's typical mathematical drawing looked like, where he did all his calculations, and what did he base it on?
We don't find any such diagrams or anything else in the manuscript, especially what I have found. Only this was the only manuscript, I think, Siddhāntic, where he has given us a diagram of Chandragrahana, that's it. No other thing we could find. They assume we know all these things, that Sulabha Sutra Vakyas and other thing, Matsimopatiya, you know all these things, just you bisect the line. What we have studied now is bisect the line with what we do with the help of compounds and other things. There they use different methods. Those things has been mentioned only in that text. There is a course done by Chanakya University recently on this particular work. So I think that is the Vanish Shri, I think. Vanish Shri.
Other questions?
I had two questions.
Yeah.
First one, in what ways are these manuscripts stored? Like, are they part of some other major books or something, or do we find them independent? And also, do we understand something about the society at that time using these texts?
Yeah, for that sake, you have to go back to interdisciplinary, multidisciplinary topics you have to study. And of course, these manuscripts are preserved and they are available at manuscript central libraries. But in Karnataka, you have it Oriental Research Institute, Mysore, we have one place. And in some places also, they have, especially colleges and universities, they have preserved all these things. We found out one in Pondicherry also, French, when we traveled to French university, and you will be mesmerized because the amount of care they take, it's as if they own your children. They don't allow anybody else to enter that particular room also. They have preserved it with full AC And the moment you enter that room, you have a lemongrass smell, so they're protected.
French
It is
Institute.
a French Institute, they have done that work, and it is available at ORI, Jodhpur, many, in Rajasthan itself we have, I think, 8 different places. And one small note, please, when you are traveling to find out all these manuscripts, make sure that you have 1 week's place so that you can stay back. Because something happens on the way, the university or the library is closed, so you have to stay back there for the entire day, and the next day will be a holiday because of something, so you have to extend your holiday for 3 more days. So you can't assume that you will travel one day and come back in the same day, it's not possible. And they give the catalog saying that this is available, and in that catalog, that manuscript itself will not be there. It will be mixed with some other misconceptions will happen because of the common names. So you require lots of time and patience to especially search these manuscripts also. Even though I think Puneet is facing that now already. Even though they say the catalog, these manuscripts are available, this is the name, all those things, it won't be strictly available in those places. You have to search. You have to search it in each and everything. You have to go through all these things, only then you can proceed. And before proceeding that, you have to be familiar with which language you are taking. Still actually, Sharda Lipi, nobody knows, it was taught in the university for us. If Kashmir's library is open, I think we'll have still, a gold, mine itself will be opened there especially. So many still manuscripts, we have not even touched it also. And there are people who are already waiting after learning all these scripts and waiting to touch those manuscripts.
Other questions? People on Zoom, you can just type in your questions on chat.
So kind of following up on Sarkar's question, so I was interested in how did the scientific work get carried forward there in those times? So like now we have citations and then we have collaborations and stuff, and then we have outreaches. Then like in those times, what was the culture of like scientific propagation or also scientific developments?
Just like you have conferences, Vakyartha Sabha and other things they do generally. Nowadays, the Vakyartha Sabha, they have, I think, I don't know other details. Varanasi, there is a place, I think it is Ramakrishna Pejataya from Varanasi, from Chanakya University. He keeps attending those places. There is a discussion which used to take place. So people used to come all together and they used to discuss all these things together. Such seminars are, today we call it as seminar and conferences. They used to call it as Vakyartha Sabha something on a particular festival or something else. That event used to take place for 7 days or 15 days where people used to, even today it happens, especially in Sringeri if you visit, for one verse, how different meanings can be interpreted. That type of sabhas take place even today also. Might be because of that we had all these things. And in one manuscript itself we can find out so many details. Then imagine the amount of manuscripts, what is available, we are already lost so many. Still whatever is available, what else can be done? There is a work by Dr. M.D. Srinivas, the untapped wealth of Indian manuscripts. Untapped, it is not even touched. So much of work is yet to be done.
Other questions? There's a question on YouTube about using AI for your work, but I'll maybe reinterpret that question as saying, things like all these automatic readers, OCR, etc. Are such tools useful?
Yeah, it is useful.
And they be trained for these languages?
But it's not 100% perfect. We tried one with one of the manuscripts. It's only some 35% perfection we could get from these things. But the happiness what you get when you use itself with those works and do is totally different from when you do it for a mission or something. You can't enjoy those things. Those are the minutes. And each moment you decipher a new word or a new letter, you get so excited as if you have achieved something. That happiness can be obtained only when you do yourself.
But it can throw some light. It's running right now.
Other comments, questions? So, just to announce maybe the Mohali thing. Do you want Okay. So there's an initiative from ISO Mohali to start a one-year course on history of astronomy in India, from ancient times up to independence. So some of us are involved in the syllabus and teaching. So that will start in July. It will be on every Saturday and Sunday for the whole year, and yeah, so then the announcement will come out. So if you want, so it will start from Shulva Sutras and end up with Kodaikanal Solar Observatory. So, it will be the first of its kind, I suppose. It will be online courses with assignments, and not exam, but assignments. So the announcement will come. So you can join and to learn more. To learn how to do all of this. Right? So there are no more questions. Then let's thank Shubha again for a wonderful talk. Very multidisciplinary, very patient, very painstaking work, and I think we hope to see more of such talk and more of such work presented here. So thanks again, and thanks everybody on YouTube and Zoom and the auditorium here for your patience. Thanks. You can stop the recording.